Alright, so assignment 2-4. Let's do this together. In question number 1, you're given that dx by dt equals 3 and x equals 4. And you're given an equation, y equals x squared subtract 2x. So our first step is we have an equation in one variable. So we're going to take the derivative right away with respect to time. So the derivative of x squared is 2x, but we need the hook. The derivative of negative 2x is negative 2, but I need the hook. So every time you take the derivative and x involved, it has that hook with respect to time. And now our goal is to find dy by dt. So the value of x is 4. dx by dt is 3. So now it's just some algebra. This is what? 8 times 3, 24, take away 6, so the answer is 18. Number 2. In number 2, dx by dt equals 10, y equals 5, and we have an implicit equation, and my goal is to find dy by dt. So step 1 again, I'm going to take the derivative. There are two variables, but we can handle two variables because we have enough information to do it. So we're going to take the derivative. So there's the derivative with respect to time. I don't know what x is, but I can solve it. So we have x squared plus 5 squared equals 169. Subtract 25 and square root, and you can see that x equals 12. The rate for x with respect to time is increasing at a rate of 10. Y, the value is 5. The rate is what I'm looking for. And now it's just algebra to get dy by dt by itself. So we have 2 times 12 times 10. That's 2 times 5. So we're going to subtract 240 and then divide by 10, and the answer is negative 24. Number 3. Technically, when you solve a square root, this could actually be positive or negative 12. So if that's the case, then this could be positive or negative 240, which makes this positive or negative 24. Number 3. The radius of a circle is changing. So dr by dt at this rate. And then it says the radius is 4. And then find the rate of change of the area of a circle. So area is pi r squared. The derivative of that with respect to time. And then don't forget the hook. And then what I'm looking for is dA by dt. The radius is 4. The radius is changing at a rate of 3. So the answer is 12 times 2. That's 24 pi. And the rate is centimeters squared per second because it's area. And that's what the rate is. There's my answer. B says the rate of change of the circumference. So there's the formula for circumference. Yes, you need to know both. The derivative with respect to time. The derivative of 2 pi r is just 2 pi. So think of that exponent. 1 times 2 pi is 2 pi. Subtract 1 to the exponent. And now we have no r's, but we need the hook, dr by dt. And then I plug in the rate for the radius, which is 3. And the answer is 6 pi. Now for circumference, that's just centimeters per second. So circumference is just a distance. So it's just centimeters. Centimeters squared would be area. Centimeters cubed would be volume. 4. Speaking of volume, a large sphere is inflated. So the volume of that sphere is, 8, I was looking at the other question, 18. And then it says the radius is 2. And it says how fast is the radius changing? So that's what I want to know. So the volume of a sphere is 4/3 pi r cubed. The derivative of v is 1, but it needs a hook. 3 times 4/3 is 4, and subtract 1 to the exponent, but it needs a hook. And then the volume is, the rate of the volume is 18. The radius is 2, and this is what I'm looking for. And then I solve it. So 2 squared is 4, so 4 times 4 is 16. Divide by 16 pi, and you have your answer. And we just need units. So if I simplified it, it would be 9 over 8 pi. And do we have units for it? Yeah, feet per minute. So radius is just a length, so it's just feet per minute. Number 5. Number 5 says, all edges of a cube are expanding at that rate. So the edge of the cube, the rate of it is 2. The radius, all instance, the edges are 5 inches long. And then find this, surface area of a cube. Well, the formula for surface area, you take one edge and square it. That's one side, and a cube has 6 sides, so that's the surface area. And then we're going to take the derivative with respect to time. And then what values do I have and what am I looking for? So I'm looking for dA by dt. So all I do is substitute in 5 for E, and the rate is 2. So it's 10 times 12, so it's 120. And the rate would be squared, because it's area. So it's inches squared per second. B, it talks about the rate of change of the volume of a cube. So that's the volume of a cube. You take one edge and you cube it. That's where we get the word cubed. There is the derivative of volume with respect to time. 3 times 1 and then subtract 1. There it is, but we need the hook. And then what information? So the edge is still 5. dE by dt is 2. And then calculate it. So 25 times 50 and 3 is 150. Yep. And then volume is inches cubed per second. Not bad, right? We can do this together. Number 6. It's always best, right, if you read it and try to understand it first and then play the video. But I get that this is a challenging lesson, a challenging assignment, and that whatever you need, you use with the video. You're given an equation, y equals the square root of x. X is changing at this rate, and it says the y value is 25. Now, if y is 25, then x must be 625, because the square root of 625 is 25. Yay? Just to think about it. I know it's tempting to say x is 5, but obviously the square root of 5 doesn't equal that. Just to let you know. I know that was a little trickery. And now the derivative. So first, it's not calculus friendly. Then take the derivative with respect to time. And don't forget the hook. And then the values to plug in. So my goal is find the rate of change of the y coordinate. So this is my goal. The x value is 625, and it's changing at a rate of 3. It's good practice. The square root of 625 is 25, right? And the negative exponent means reciprocal. So if I put this together, it's 3 over 50. And then the unit would just be centimeters per minute. All right, number 6 is done. Number 7, try first. Read it, try to comprehend, and then play the video. So a 10-foot ladder is leaning against a house. The base of the ladder is pulled away from the house. So here's the base of the ladder. So that rate is being pulled out at a rate of 1.5. At the instant the base of the ladder is 6 feet. And then we have questions to answer. I'm going to call this A. And then I'm going to answer A. Find the rate at which the top of the ladder is moving. So as the ladder slips, A here, that rate is what I want to find. So I should start with A squared plus B squared equals C squared and solve that. If you solve it, it's also a Pythagorean triplet. A is equal to 4. It's 100, take away 36. Oh, sorry, not 4. 8. That's 100, take away 36, which is 64, and the square root of 64 is 8, or 6, 8, 10 is also a Pythagorean triplet. You need to solve it. It's 8. And then the equation. Now, in this case, I can put 10 in immediately before I take the derivative, because the length of the ladder stays the same over time. It never changes. So something that's constant, you put in first, before the derivative. Then you take the derivative. A and B, those lengths are changing over time. So you take the derivative with respect to time. The derivative of any constant is 0. Then put in the values. So A what is it? Sorry, A is 8. We're looking for this. This answer should be negative because it's getting shorter over time. B is 6, and the rate for B is 1.5. And that's what I'm going to answer. So this is 16, 12, and half of 12, that's 18. Subtract 18. So if I subtract 18 and divide by 16, I don't need to simplify it. The units would be feet per second. So that's the rate it's moving, this ladder here. B, find the rate at which the area of the triangle formed is changing. So area is half the base times the height. In this case, the height is A, so I'm using A. Take the derivative. Now, to take the derivative here, we need to do the product rule. So that's the first times the derivative of the second plus the second times the derivative of the first. I don't know why my brain needs to, like D and B, my brain takes a moment to think about it, make sure I have them written properly. And now we plug in the values. So we said B is 6 dA by dt. We just found that is negative 18 over 16, or negative 9 over 8. A is 8. And then the base, the rate for the base is 1.5. And now I just have to calculate that. So half of 6 is 3, that's negative 27 over 8. Half of 8 is 4. 4 and 1, and half of 4, that's 6. You can get common denominators. And 48 take away 27. You get 21 over 8. And what's for area? That would be feet squared per second. See? Is the area from part B increasing or decreasing? So the rate is positive. Therefore, area is increasing. And the question is, would your answer be the same at all times? The answer is no. As that slips away, this area will eventually be decreasing. And it has to do with these two numbers. So eventually, this number in front will be more negative than this number after in terms of it. So as the ladder slips, there'll be more negative and less positive. So over time, the area will decrease. Part D. Let theta be the angle formed by the ladder and the house. So let me just draw this again. So you know this is 10. This theta is right here with the ladder and the house. This is A and B. Find the rate of change of theta with respect to time. So we need an equation for theta. So this is trigonometry. So you could use A or B. So I'll use B. So opposite over hypotenuse is sine. So sine theta is equal to B over 10. To get theta by itself, you do inverse sine. Well, first, let's first just take the derivative. So the derivative of sine is cosine, but we need a hook. And then the derivative of this is just 1/10, but we need a hook. Then we put in the values. So in the question, it says find the rate. So I'm looking for this. Theta how did we find theta? Oh, cosine theta. So cosine theta is adjacent over hypotenuse. We know what A is. So this value here is 8. And this is 6. So cosine theta is adjacent over hypotenuse. That's 8 over 10. And d by dt is 1.5, or 3 over 2. And then if I put that together, I'm running out of space here. I got this. This is 3 over 20. And then instead of dividing, I'm going to go times the reciprocal to get it by itself. That's 2. That's 3 over 16. Yeah. And that's in radians, right? Per second. That was tricky, right? We did it together. Number 8. Let me get paper. In number 8, a rectangle is formed whose length is twice the width. The rectangle, it is enlarged to a similar rectangle as the width changes at a rate of 4 inches per minute. When the width is 10, how fast is the area increasing? So if the width is 10, then the length must be 20, according to this. And area is length times width. So I'm going to do a substitution. My goal is how fast is the area changing? So I know this. So I want things in terms of W instead of L. So I'm going to take out L and put in 2W. So we have 2W squared. And then take the derivative. And the reason I want one variable, because I only know one rate. If I knew the rate for L, it wouldn't matter. But I only know the rate for the width, so I had to change it in terms of only the width. And now I substitute in. So the width is 10 and the rate is 4. So that's 16 and a 0. And then what's that is inches per minute. In its area, so it's inches squared per minute. Number 9. A sand is added to a conical pile, so I'm given the rate for the volume is 8. The diameter is twice the height. Now, diameter is twice the radius, so ultimately the radius is equal to the height if you divide by 2. It says find the rate of the height. That's what I'm looking for. When the volume of the pile is 1,125 pi, and so on. So that's what I'm looking for. So first I need to know the height of the pile. So I'm going to do that right now. So volume is equal to 1/3 pi r squared h. Now, I want things only involved in terms of h. So I can take out the r and put in h. So instead of 1/3 pi r squared h, I can do this. And it says that's the volume. So now I'm going to find the height. So I plug in that for it. So I'm going to multiply by 3. The pi's divide out. And then the cube root of that, believe it or not, the cube root of that is 15. So 15 times 15, you could definitely use a calculator here. So it's 15 is the height. So I need to find that out. So we come back here again. I'm going to use this and take the derivative. So the derivative with respect to time, 3 times 1/3 is 1. Subtract and then the hook. So there's the derivative. The derivative is changing at a rate of 8. The height is 15, and this is my goal. This is what I'm looking for, dH by dt. So I'm just going to divide. That's 225 pi, and the units would be feet per minute. This is dH by dt, and then it says, if you wrote a sentence, you would say the height of the pile is changing at a rate of 225 pi feet per minute when the volume is, because that's what was given. And then you have your sentence. So the height of the pile is changing at a rate of that per minute when the volume is that, and it's perfect. Number 10. In number 10, a bicyclist and a jogger are moving on 2 perpendicular intersecting streets. The bicyclist is moving north towards the intersection. And the jogger is moving west. So we got north and west, and we're going to connect these together. The first number is 60. That has to do with the bicyclist. That's the rate. The next number is 15. The rate of the jogger is 15. Just reading it and knowing what each number represents. What is the rate at which the straight line distance between them is changing? So this here, I'm going to call that C. That's what I'm looking for. That's my goal. When the bicyclist is 120 feet from the intersection and the jogger is 50 feet from the intersection. So there's all the information. That's what I'm looking for. So first step is to find that. We don't know it and we need it. So the equation is that we have 120 squared, we have 50 squared, and see, I don't know if it's a Pythagorean triplet. it is. So if you solve this and square root it, you get 130. All right. So now I have the values that I need. So what's the equation that puts them together? That's here. So the derivative of this is 2b and then the hook, 2j and then the hook, and 2c and then the hook. And now it's algebra time. So b is 120. The rate for b is 60. Now the rate for b might be negative, right? So notice this distance here is getting shorter as it's going to the intersection. So this is going to be a negative 60, something to always be aware of. J is 50. The rate for J is 15. It is getting bigger, so it's positive. C, we says 130, and I'm looking for this. This is my goal at the end. Kind of ran out of space there. So if I multiply that together, that's negative, 1,140, 12 and 12. If I multiply this together, sure, I have room here. I'll do it down here. Make sure I have room. So if I multiply that together, if I multiply this together, that's 30 and 5. So 3 times 5, 30 and 5, and a couple zeros. And then if I put that together, this is what, 260? So this is going to be negative 64. I'm just doing the heavy work here. So if you do this in your calculator and divide by 260, you should get negative 49.615 feet per second, and you did it. So the distance between them is shrinking at that rate at that time. So they're getting closer to each other at that rate. Number 11. We have 2 more related rates to practice, and then the rest is review. If you need a break, take your break. At halftime of a football game, 2 fan volunteers are attached together with a bungee cord and positioned at the 50-yard line. One runs along the sideline, and the other runs along the 50-yard line. So it kind of has this. So one is running at a rate of 4 yards. The other is running at a rate of 3. And this is at what rate is the bungee cord being stretched when the sideline runner reaches the 30-yard line? So if you start at the 50 and you get to the 30, then this distance is 20 yards. Because you started at the 50-yard line and 30-yard line, that subtract it, and that's where 20 comes from. Now, to understand what B is, we need to understand the rate. So, if the rate is 4 yards per second, then it must take 5 seconds to get to 20 yards, because 5 times 4 is 20. So it's 5 seconds. So 5 times 3 would make this is 15 going at that rate. Understanding the time involved. So then a squared plus b squared equals c squared. That's what we're solving. And then square root. So C is equal to 25. Our goal is, at what rate is the bungee cord being stretched? So that's what's connecting them. That's the hypotenuse. So this is my goal. Alright, so it should be much easier now. All values are changing over time. Take the derivative with respect to time, and then it's just algebra. So all the hard part was the setup. At this step, it should feel simple to take the derivative with respect to time in the hook, and then plug in the values. So we have 20, and the rate is 4. We have B is what? 15, and the rate for B is 3. And then 25 for C, and the rate for C, that's what we're looking for. And that's what I'm going to solve. So if I solve this, 2 times 20 times 4, 2 times 15 times 3, add them together. That number is 250. This is 50. Divide by 50, and you get 5, right? And that's your answer. So the rate the bungee cord is being stretched is 5 yards per second. Number 12. A base runner who is running at a rate of 25 feet per second is halfway to first base. Find the rate of change of his distance from second base. So there's a triangle there. So if you see a picture in your book, I'm just going to redraw this triangle here, and it's a right triangle. So there's the right triangle. So this is 90 feet, that's baseball. Halfway would mean this is 45 feet. And then I need to know that distance. So that's how you would solve for that distance. And a decimal, it would be what? 100.623. So if you solve for this in square root, that's the approximate answer. So I'm going to label this B for the base runner. So this 90 feet stays the same. This is a constant. So as the base runner is running, this is changing, C is changing, but 90 stays the same. That's important to know, because I can go 90 squared plus B squared equals C squared and take the derivative, and then the derivative of 90 squared is 0. So here's the derivative with respect to time, and then plug in the values. So B is 45 feet. The rate for B, how fast is the baseball runner going? 25 feet per second, so that's in the question. C, we found, was about 100.623, and this is what I'm looking for, right? The change in his distance from second base. So this is the rate there is what I'm looking for. So if you multiply and divide with your calculator, you get the answer, negative 11.180, and that's feet per second. So what that means, because it's negative, the distance the runner is to second base is getting smaller and smaller as it's getting to first base. Done. All right. We can breathe through it. Okay, now no more related rate stories. Now it's review. Very important. So you have the function x cubed subtract 3x, x squared subtract 4. To take the derivative is the quotient rule. The bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. Number 14. I'm going to write that calculus friendly. That's 2x subtract 1 to the half, 3x plus 1 to the third. This is going to be the product rule. What's the product rule? The first times the derivative of the second. That's 1/3, 3x plus 1, subtract, and then there's a little hook, plus the second times the derivative of the first, and then don't forget the hook 2 at the end, the derivative of 2x, subtract 1. That was 14. 15, find an equation of the tangent line. So for that, I need to know 3 values. It says x equals 0. To find y, I plug 0 in for x and solve it. So you end up with 2 to the 4th, which is 16. And then we need to know the derivative of that with the hook at the end. And then we plug in 0 for x. Now 6 times 0 is 0 times anything. So the slope is 0. So it would be y equals, now do I really need to go do this part? 0 times x minus 0? No. All I'm left with is 16. So it's just y equals 16 is the equation of the tangent line. 16a. So you're given a function, and A says, can you find the average rate of change? So, and it's between 1 and 3. So the average rate of change is this. F at 3 subtract f at 1, or y2 minus y1, and then subtract the x's. If you plug 3 in, I get 12 divided by 3. Plug 1 in, it's 4 divided by 1. So that answer is 0. B, instantaneous rate of change means derivative. So to take the derivative here, I'm actually going to rewrite this. X squared over x and 3 over x. That would be x squared divided by x is 1x, and this would be 3x to the negative 1. So the derivative of x is 1, and the derivative here is negative 3x subtract 1. So there's the derivative, and then it says find it at 3, right? Now, if I wanted to simplify it, 3 squared is 9, and that would go in the denominator, so it's 1 take away a third. So it is 2/3 if I needed to simplify it. Number 17. We're almost there. In number 17, what is the derivative of the function from the left? So we have a function, x subtract 1 cubed and x subtract 1 squared. And say, what's the derivative from the left? We could actually write that as a limit. So the derivative is 3x minus 1 squared, and that's it, no hook on, and then plug in 1, and so the answer is 0. B, what's the derivative from the right? So that's 2, and then plug in 1 for x. That's also 0. And then C, does the derivative, is it differentiable? So the answer is yes, because they have the same answer. Number 18. So what's the derivative from the left? So what's the derivative from the left? Maybe it's just maybe this is smart to do at the beginning. So the derivative here would be 2 times a half, which is 1x, and the derivative of negative a half is 0, and the derivative here is 1. So plug in 1, you get the answer 1. B, the limit from the right, what's the derivative? Plug in, the answer is always 1. And then C, do they match? Is it differentiable there? And the answer is yes. Number 19. So right away I'm going to do the function and the derivative. We just did this one. This is a trick one. Do you notice there's no line underneath the arrow? So part A from the left, it's 1. From B, it's 1. But you know what? It doesn't exist. And why doesn't the derivative exist? Because at x equals 1, there's a hole. Because this function is not equal to 1. Because it's less than 1 and greater than 1, there's a hole at 1. And so therefore the derivative does not exist. Tricky. It's not continuous there. Number 20. So we have a function. The derivative of that function. Right away, right? Might as well. And then after you take the derivative, what's the derivative? When you plug in 1, the answer is 0. When you plug in 1, the answer is 0. And then why does the derivative not exist? Because it's not continuous. There's a jump. If you plug in 1 to the top, the answer is 0. You plug 1 into the bottom, the answer is 1. There's a jump. And so because it's not continuous, because there's a jump at 1, so from the left and right, they seem like they have the same derivative, but it doesn't exist because it's not a continuous function at 1, because there's a jump. 21. Use limit notation to find the derivative. So if I want to find the derivative, limit notation to find the derivative. There's a good start. X plus h. X plus h. So you plug in x plus h, subtract parentheses, then the function, and that's what I'm solving. So if I multiply this out, it's x squared plus 2xh plus h squared minus x minus h minus x squared plus x. X squared and negative x squared, negative x and x. And then I'm going to factor out an h. That leaves me with 2x plus h minus 1. The h's divide out, plug in 0 for h, and you have 2x subtract 1. 22. We just did, we did 21. 22. 3 left. In number 22, y equals, it is not calculus friendly, so I'm going to do it right away. So now it's calculus friendly. Find the second derivative. So the first derivative, subtract 1. The second derivative, subtract 1. The next derivative, a negative times a negative is positive 6, even if you can't see it. And then subtract 1. A negative times a negative is positive. The 1/2 times 2 is 1. I don't need a 1x, and then there's the derivative. (23). In number 23, it says find an equation of the normal line. So we're still going to do this. We just need to know to do the perpendicular of that. x and y is given. We're given that we're going to make this calculus friendly. 2x subtract 1 to the 2/3. Take the derivative. Subtract 1 from the exponent. There's a hook. The derivative of 2x is 2. And then I need to plug in 1 for x to find it. So 2 times 2 is 4/3. If I plug 1 in for x, 2 take away 1 is 1, and 1 to any exponent is 1. Now, for the normal line, I need to do the opposite reciprocal. And then everything else is the same. All right, last one, 24. We got there. And it's 46 minutes. Probably felt like 8 hours. It's not even an hour. 24. R at 3 is -2. S at 3 is 2. R derivative at 3. S derivative at 3. R derivative at 2. All kinds of great. And then this is what I'm asked to find. All right. So take the derivative with respect to time. Now notice t is the variable, so we don't need the extra hook here. And then we have r at s at t. So it's the derivative of the outside times the derivative of the inside. This is the chain rule with a composite function. So the derivative of the outside times the derivative of the inside. Plug in 3 for t, and then let's plug in values. So s at 3 is 2. S prime at 3 is 5. R prime at 2 is 4. And then 4 times 5 is 20. You got your answer. Mr. G Math, over and out. I am proud of you. This was not an easy assignment, but you got to the end and you're trying your best. And I appreciate you. All right, till next time.